All right, AP Calc, welcome. Let's do this. So here we will take the derivative of all the trig functions. So we're very comfortable with sine and cosine, but what about the other trigonometric functions? So here we have d theta. So you're taking the derivative of sine of theta with respect to theta. So this is just simply what's the derivative of sine of theta? So it's cosine theta, right? The derivative of cosine theta is negative sine theta. What is the derivative of tangent theta? It is secant squared theta. What is the derivative of cosecant theta? That is negative cosecant theta times, what is it again? Cotangent theta, right? What's the derivative of secant theta? It's positive secant theta times tangent theta. And the derivative of cotangent theta is negative cosecant squared theta. Okay? So you just have to get used to these trig functions. And just so we're all okay with pronunciation, right? This is sine, cosine, tangent, right? This is cosecant, this is secant, and this is cotangent, okay? And how do we actually, work with the trig functions? We'll do that in the next part of the lesson. But for here, let's just have fun and take the derivative. So here, let's look at the first one. We have cosine cubed x, right? So first, notice that cosine cubed x is the same as cosine of x, the whole thing cubed, okay? And the reason we're going to want to set this up like this, so here we have f of x is equal to cosine of x, right? The whole thing cubed. And the reason why we want to have it like this, because we will use the chain rule, right? So we need to use the chain rule over here. So chain rule. And then what I want you to do is set it up. What's the red? What's the blue, right? Outside, inside. So here, this is our outside. And this is our inside. Okay? And now here, we'll take the derivative of this. So we say f prime of x is equal to 3 times. Here, let me zoom in a little bit. Okay, that's a little better. 3 times cosine of x, and this will be squared, times, we got to take the derivative. Remember, I see a lot of people lately, what they would do is they would do 3 over here, and then they take the derivative of cosine and put sine here. Don't forget that. Remember, this stays the same, and you're going to take the derivative of the inside, right? So the derivative of cosine of x is negative sine. Oh, wait, no, I don't want to do that yet. I want to say the cosine of x, and I want to take the derivative of it, right? So f prime of x is equal to 3 times cosine of x, the whole thing squared, times the derivative of cosine of x is negative sine of x. Like, I was going to write negative sine x here, but you remember, I don't want to skip steps. I don't want to be like some students in the classroom, right? All right, so here, what happens next, this becomes, here we distribute put the negative over here. So this is negative 3 cosine, and don't you remember, the same way we put the 3 on the outside, we're going to put the 3 or the exponent back on the inside. So this 2, we're going to bring it back from the outside to the inside, cosine squared x times sine of x, okay? And that is the derivative of f of x, right? Okay, let's look at the next one. So here we have 3 cosecant x. Now don't freak out. Here, how do you take the derivative of this? You just say g prime of x. Now here, we're not using a chain rule or a power rule or product or quotient rule. Here, because it's just cosecant x, right? We just take the derivative of cosecant x. So it's going to be 3 times, what's the derivative of cosecant? Well, the derivative of cosecant is negative cosecant x times cotangent x. And wow, that's it. That's all you have to do, right? And that's the answer. So it's just, actually, I'm sorry. You do want to have it like this, because you want to have it as negative 3 cosecant x times cotangent x, right? Now that looks much better, and let's underline it with our green box over here, right? Okay, let's look at the next one. We have 3 cotangent 2x. Now here, we definitely want to use the chain rule. So what I want you to do is try and set this up on your own, okay? What's the setup? Here we have h of x is equal to, okay, this is 3 cotangent, and then this will be the setup. You see here, the 3 cotangent will be the red, will be the outside, and the 2x will be the inside. So now we have h prime of x is equal to, okay, so 3 times, well, what's the derivative of cotangent theta? So derivative of cotangent theta is negative cosecant squared theta. So we're just going to write negative cosecant squared 2x, right? We're going to take it's cosecant squared 2x times the derivative of what's on the inside, which is that 2x, right? So now we have h prime of x is equal to negative 3 cosecant squared 2x times 2. So h prime of x is equal to negative 6 cosecant squared of 2x. And then bam, this one is done. Okay. Let's look at the next one here. P of x is equal to secant 2x. So here, this is just simply the derivative of secant 2x, right? No need of a chain rule or anything. So here, p prime of x is equal to, well, what's the derivative of secant? The derivative of secant is secant theta tan theta, or secant x tan x. So this is just secant 2x times, oh, actually, wait a minute, hold on. You do have to use a chain rule. I am very sorry. You absolutely have to use a chain rule. So here, let's just pause for 1 second. Why do you have to use a chain rule? Here, p of x. Now here, what is our outside inside? Here, this is secant, would be the outside, and 2x will be the inside. Okay, so good thing I caught that. So here, we got to take the derivative of, so p prime of x is equal to, okay, so secant 2x is going to be secant 2x times tangent 2x, right? This, you see, this secant 2x times tan 2x, this represents the red. Now we got to take the derivative, we took the derivative of the red. Now we're going to take the derivative of the blue times the derivative of 2x, right? And then so p prime of x is equal to secant 2x times tangent 2x times 2. So this just becomes p prime of x equals 2 times secant 2x times tangent 2x. And then that should be it. Okay. All right. Let's look at the next one. Here, we have, what do we have here? We have s of x is equal to sine cubed x. So what I want you to do is try and do this problem yourself, and it's very similar to the cosine cubed x, right? Try and look at number 1 for a little preview, right? Okay. So what's the move? So you know that sine cubed x is the same as sine of x, the whole thing cubed, right? So then that's the little trick we're going to do here. We're going to say s of x is equal to sine of x, the whole thing cubed, right? And then now here, once we have this set up, now we're going to use our red and our blue. This is the red, and then this will be the inside, which represents the blue. And notice that we are using a chain rule. Okay. Okie dokie. So now we have s prime of x equals, well, what's the derivative? Oh, oops, sorry, I forgot. There should be a 3 here. What's the derivative of the red? So this is 3 parentheses sine of x squared times the derivative of the blue, what's in the inside, so derivative of sine of x. Okay, so s prime of x is equal to 3 times sine of x, the whole thing squared, times cosine of x. Okay, so s prime of x is equal to 3. Now, the same way we got to do this move, the same way we brought the 3 outside, the same way we brought this 2 on the outside, right? We're going to bring the 2 back on the inside times cosine of x. And this will be the derivative of sine cubed x. Okay. All right. Let's have fun. Let's go with the next one. Trust yourself, right? Like, you can do this, right? This, oh, look, we just did this, right? It's just, instead of sine, we're doing secant. And we know the derivative of secant, right? So what's the move here? Here we have secant cubed x is the same as secant of x, the whole thing cubed. So we have t of x is equal to secant x, the whole thing cubed. So t of x, now this is the setup, right? Always set this up. This is the red, and here's the blue, secant x, right? Okay, so now let's take the derivative. So t of x, t prime of x is equal to 3 secant x, the whole thing squared, times the derivative of the blue, which is secant x, right? So the derivative of secant of x. Okay, so now t prime of x is equal to 3 times secant of x, the whole thing squared, times the derivative of secant of x. So pause the video. What is the derivative of secant x? The derivative is secant of x times what is it? Tangent x, right? Okay, so tangent x. Okay. Now, once you get to this point, you say, "Oh, Mister, all right. So now I know what to do. I do this, and then you see I bring the square here. So 3 times secant squared x times secant of x times tangent of x. And if you left it like this, it's almost done, because notice that if I have a secant x and a secant x, like I can combine these two. What do you think this will combine to? Notice that what's the exponent here? 2. What's the exponent over here? Is that invisible one, right? So we have t prime of x is equal to 3 times secant cubed x times tangent of x. And that is the derivative of secant cube x. Okay, these are fun, right? That was a little fun little trick here. We didn't have that before. Okay, try these on your own, right? You got this. Okay, so now here we have s. What is the derivative of s, right? So here we have s is equal to, all right, notice that tangent squared x is the same as tangent of x, the whole thing squared. Okay, so let's continue, right? So the way we would set this up is 3 times, let's see, parentheses. You know what? Just so I don't make any careless mistakes, I'm going to do 7, 8, and 9. I'm going to do these 4 on my own in the next video so I can make sure they're nice and smooth. But try and do them on your own, and I'll have it in the next video. All right, hope you're doing well.